In this short video, I will go over how to write a thermochemical equation. We'll start with this example. When 0.231 grams of phosphorus reacts with chlorine to form phosphorus trichloride in a constant pressure calorimeter of heat capacity 216 joules per degree Celsius, the temperature rises by 11.06 degrees Celsius. Write the thermochemical equation. So when we talk about a thermochemical equation, what we're talking about is writing down the balanced chemical equation with the change in enthalpy right next to it. So in this case, first we need to identify how much heat was released in this particular case. And the device that was used here was a constant pressure calorimeter, and that is the same as what we call a coffee cup calorimeter. Okay, so it's a constant pressure calorimeter, which means that the Q is going to be the Q at constant pressure, which is going to equal the change in enthalpy for the reaction. It's going to equal QP in this case. And so we're given the heat capacity of the calorimeter. Again, this particular calorimeter has been calibrated to include the entire device. So we just need the one heat capacity of the calorimeter and the temperature change to calculate QP in this situation. So QP is simply going to be the heat capacity of the calorimeter, sometimes that's called the calorimeter constant, times the change in temperature. So it's going to be 216 joules per degree Celsius times 11.06 degrees Celsius. So the heat given off here at constant pressure then is 2,389 joules given off in this case. So that's how much heat energy was absorbed by the calorimeter. All right, so that was absorbed by the calorimeter. Alrighty, and so we want to write the thermochemical equation. So the next thing we need to do is write the balanced chemical equation. Okay, and so the balanced chemical equation is that phosphorus reacts with chlorine to give phosphorus trichloride, and we need to balance that reaction. So there's 3 chlorines and 2, so we're going to have to put a 2 here, a 3 in front of the chlorine, and then a 2 in front of the phosphorus to balance out the phosphorus. So that's the balanced chemical equation. We want to write down the change in enthalpy for this reaction. Okay, that's what we're going for now. Now the heat that was absorbed by the calorimeter is going to equal the heat that was released or given off by the equation. All right, and so that's going to be a negative. It's going to be an opposite sign. So that's what was given off. Negative 2,389 joules of heat energy was given off by the reaction when we reacted 0.231 grams of phosphorus. So we need to normalize this heat, divide by the amount of phosphorus that was reacted in that case. Now, to convert this value here, which is just the heat released by this equation, then we need to we want to actually express that as the heat of reaction. Then it's going to have to not be per gram of phosphorus, but rather we're going to have to express this in terms of joules or kilojoules per mole reaction in order to write the change in enthalpy for the reaction. So at this point, we are in units of joules per grams of phosphorus. And so what we have to do at first is convert to moles of phosphorus using the molar mass of phosphorus, which is from the periodic table, is 31 grams of phosphorus per 1 mole of phosphorus. That's the molar mass of phosphorus in the periodic table. Now I'm in units of per 1 mole of phosphorus, but when I look at this balanced chemical equation here, it's 2 moles of phosphorus plus 3 moles of chlorine gives 2 moles of phosphorus trichloride. So I need to express this in terms of mole reaction rather than moles of phosphorus. So every 2 moles of phosphorus that react, I run 1 mole reaction here. So I need to normalize to mole reaction. Now the grams of phosphorus units will cancel, the moles of phosphorus units will cancel, and I'll be left in units of joules per mole reaction. And so when I do the math here, I'm going to end up with a negative 641,203 joules per mole reaction. We will write that in a more understandable way and say it's 641.2 kilojoules per mole reaction. And that's a negative value because the heat was released. So then here, this mole reaction value, when I write the thermochemical equation, should be written next to it. All right, and so in that case right here, I'm going to give myself some space and say the heat of reaction in this case is negative 641.2 kilojoules per mole. Sometimes it's written as kilojoules per mole, but you need to recognize that that means per mole reaction when it's given as the heat of reaction or the change in enthalpy for the reaction.